Hello and welcome to the first lesson of our new unit. We're going to explore what are called rational expressions. So let's talk about what it means to be a rational expression. Basically, it means if you take any polynomial and you divide it by a polynomial, this is what we mean by a rational function. Another synonym for rational is fraction. So another way that sometimes they will word it using English words, it is when you have an expression in a numerator and in a denominator. So I want you to notice how all of the work that we're going to be doing has to do with fractions, but don't fret. This section isn't too bad to deal with. If anything, it's more of a factoring review than anything else. The one thing I wanted to note is I want you to go ahead and draw a line that separates problem 6 from problem 7. There is a distinct difference between them. On problems 1 through 6, problems 1 through 6 are what I call monomial problems. That means the numerator and the denominator each have one term. We have a different strategy than when we deal with the problems below that are polynomial in nature. So we're going to do problems 1 through 6 right now, and then I'm going to ask you to pause, stop the video, and then go do the homework problems that associate with that, and then come back. All right, here we go. Problem 1. What do we do first? In order to simplify, you want to look at the number family first. So I have 12/48. So you can use a calculator to reduce it, and it reduces to 1/4. Then I look at the variable family, and I see y over y to the third. You can use properties of exponents that tells you to subtract the powers, or remember this means y over 3y's. And this y cancel and that y cancel, leaving you a 1 over 4y squared as your final answer. Let's do problem 2. First, focus on the number piece. You can use a calculator or your brain to reduce it. Since 7 goes into both, 21 over 35 reduces to 3/7. Again, use a calculator if you're wondering where I'm coming up with that. The A and the A cancel, so that means there are no A's in my final answer. When I look at the B family, this means B over B times B, leaving me 1B on bottom, so 3 over 7B is my final answer. Let's look at problem 3. Start by looking at the number family. Reduce 8/24 using your brain or a calculator. It reduces to 1/3. Now, the M family has 2 M's up top and 1 M on bottom. So I'm left with a 1 M on top. And then when I look at the N family, I have 1 N on top and I have 3 N's on bottom. So that leaves me with an N squared on bottom. Please note that an answer key might not post the 1. They just might post the final answer as M over 3N squared. All right, let's do number 5. Okay, number 4. Learn to count, Nop. All right, we aren't going to approach this any differently. It's just instead of having just an X family, we have the X and the Y. So again, I'm going to look at 16 over 36. You can use a calculator or your brain to reduce. And this is going to reduce to 4/9. I have 3 X's on top. I have 5 X's on bottom. So when those cancel, I would be left with 2 on bottom. And then when I look at the Y family with 3 on top and 2 on bottom, I would be left with 1 Y on top. For number 5, again, look at the number family. And when I look at the number family, I'm going to reduce 12/40. Again, use a calculator or your brain. It's going to reduce to 3/10. Then look at the A family. There's 2 on top, 3 on bottom. So that means you'd have an A on bottom. And then when I look at the B family, I have 3 B's on top, 1 on bottom. So that means I would have a B squared left in the numerator. And our last monomial problem All right. Again, we always focus on the number family first. It reduces to 2 over 1. When I look at the x family, I have an x on top, 2 on bottom, so that leaves me an x on bottom. I'm also left with a y on bottom. And then when I look at the z's, I would be left with a z squared on top. Please note that an answer key probably wouldn't print the 1, and it would leave my answer as 2z squared over xy. So at this time, I would stop the video and I would head on over to your homework and do problems 1 through 3. So these 6 examples correspond to 1 through 3 on your homework, and then come back later and continue. All right, friends. So to continue with the rest of this assignment, all right, we are now into the part where these are polynomials. So we cannot attempt the same strategy. So I want you to keep your pens down. Keep your pens down until I erase this. You may not cancel out those n's. Why? Because this n, this n is attached to the 6 by a plus. When I have an n, that is a single monomial. But when I have an n plus 6, this is now 2 terms. This is a binomial. The only way that I can cancel out another n plus 6 is if I have an n plus 6 on top and bottom. So friends, I'm not trying to make a political statement. I call anything that is attached to something else with a plus or a minus, I call it a married term. Again, I'm not trying to make any kind of political statement on what people think about marriage, but just they're binds that tie. So I can't separate the n and the 6. So how do I go about this problem? Now pens up. Okay, so now pens up. All right, use your pen. Okay. When we talk about these polynomial problems, the first thing you need to do is you need to factor. When I look at n plus 6, there is no GCF, it has 2 terms, and it does not follow a difference of squares. So the numerator is just going to stay n plus 6. But the denominator has a GCF of 3, so I'm going to take the 3 out. Now, this is how I categorize. 3 is a monomial. N plus 6 is a binomial, and this n plus 6 is a binomial. A monomial can cancel out a monomial. A binomial can cancel out a binomial. Well, the n plus 6 are the same. They can cancel out, which gives me a final answer. When this cancels out and there is nothing left, it's not a 0 because 0 is an additive identity. We canceled out over division. So when we think about how division and multiplication are related, you get a 1 as the multiplicative identity that's left over. Okay, let's do another one. 4x minus 4 over 4x plus 4. I cannot stress this enough. You cannot just start canceling. You may not do that. Why? Because you have a minus and a plus. Those operations mean that these are not monomials. They are binomials. So the only way I can cancel out a 4x minus 4 is if there's a 4x minus 4 on bottom. Or how can you cancel out a 4x plus 4 over a 4x plus? That's the only way that they cancel, friends. So how do we actually do the problem? We factor. I look at the numerator. What's your first rule of factoring? The first rule of factoring is take out a GCF. They share a 4. The denominator shares a 4. Well, this 4 is a monomial and that 4 is a monomial, so they cancel. The x minus 1 and the x plus 1 do not cancel. There is nothing you can do. This is your final answer. And if you want more of a reason why, let x equal your favorite number. My favorite number is 4. If I put in 4 minus 1 and 4 plus 1, friends, again, this was an arbitrary number I picked. Don't I get the number 3/5? If you say the 4s cancel, then you get -1 does not equal 3/5. If you cancel out the 1s and say that you guys, that's not equivalent. So that is why you are not allowed at this point to cancel any further, unless the only reason you could cancel out an x minus 1 if there was another 1 on bottom, and there isn't. And the only way I could cancel out an x plus 1 is if there was an x plus 1 on top, and there isn't. So that's why this is our final answer. You cannot cross out anything after this point. You can't. It's not equivalent. Okay, let's do problem 9. And if you're wondering, Mrs. Knopp, how do I factor again? Well, remember that you have your graphic organizer. It should be on yellow cardstock. So this is where I'm coming from. For step 1, we take out a GCF. Then we count the number of terms. And if you look at the numerator in the last problem, it follows a difference of square pattern. So how do we deal with this? The numerator, when it factors, becomes y plus 8 times y minus 8. The denominator y plus 8 does not factor. There's no GCF. It is not a difference of squares. And I know it's not in parentheses, but notice how I have the binomial y plus 8 and y plus 8. And friends, that can cancel to give me a final answer of y minus 8. If you want to write it as y minus 8 over 1, that is okay, but an answer key probably won't publish it that way. All right, let's keep going. When I have to look at number 10, again, if you want to do this, don't. Those are not monomials. The denominator is a binomial. It has 2 terms. The numerator is a trinomial. It has 3 terms. So the only way that you can cancel is if they look exactly like itself on the top and the bottom. So how do we do the problem? We have to factor it. All right, so let's go back to our factoring graphic organizer. The numerator has 3 terms. Well, it's easy because it has a leading coefficient of 1. So I just have to figure out 2 numbers that multiply to give me a -18, but at the same time add to give me a -7. And those numbers are going to be a 9 and a -9 and 2. So that means the numerator is k minus 9 times k plus 2 all over k minus 9. And then hopefully you're starting to get the hang of this. K minus 9 are both binomials, so they can cancel each other out, leaving me with the final answer of k plus 2. So what is the name of the game here, guys? We factor and then we cancel. And your rules for canceling is that you can only cancel a monomial over a monomial, like in problems 1 through 6. Or you can only cancel out a binomial and its same binomial, or a trinomial and its same trinomial. They have to be the same married factor. All right, here we go. In this problem, z plus 1, the numerator does not factor, but the denominator has 2 terms, and it follows a difference of squares pattern. So I get z plus 1, z minus 1, and these are the ones, star this, because these are the ones that sometimes kids mess up. You get this, oh, excuse me, hold up, okay. You get this much. But when this cancels, remember this is the multiplicative identity, so this cancels into the number 1. So my final answer is 1 over z minus 1. You don't have to put the parentheses, but if you do, it's still full credit. Number 12. Number 12, again, resist canceling that. That is incorrect. That's like saying 5 plus 6 over 5 squared plus 2 times 5 minus 24. You guys, those don't cancel. 5 over 20, does that make sense? That does not cancel correctly. That's 5 over, it's not the same. So what do? We factor, and then we cancel. All right, so we have x plus 6, which does not factor, and the denominator is 3 terms. Again, it is easy because the leading coefficient is 1. So I need to find 2 numbers that multiply to give me negative 24 and that add to give me 2. And those numbers are going to be 6 and negative 4. So this factors into x plus 6, x minus 4. Be careful with your final canceled answer. The x plus 6 cancels, but remember, we're in multiplication and division, so it doesn't cancel to be 0. It cancels to be 1. So I get 1 over x minus 4. Again, if you want to put that in parentheses, that's fine. All right, here we go. We're going to start putting some skills together. My first rule of factoring is a GCF. So in the numerator, I have 2 that's in common. So I can pull out a 2, and I'm left with d plus 5. D plus 5 is 2 terms, but it does not follow a difference of 2 squares. The denominator is 3 terms, so I have to find 2 numbers that multiply to negative 35, but at the same time add to give me negative 2. That's going to be a negative 7 and 5. So this factors into x minus, that should be a d, pardon me. So that should be d minus 7 over d plus 5. The d plus 5s do cancel because they're both binomials, so your final answer is 2 over d minus 7. Problem 14 is a very similar problem. We can take out a 3 in the numerator because that's my greatest common factor. The denominator is 3 terms, so I have to find 2 numbers that multiply to give me to 15, but that add to give me to negative 8. So that's going to be a negative 3 and a negative 5. So I end up with h minus 3, h minus 5. That's the factoring part. And then now I'm ready to cancel. H minus 3 and h minus 3 are both binomials, leaving me with a final answer of 3 over h minus 5. At this point, if you want to try a few on the homework and stop, that's great, because the rest of this is really just factoring. It's reminding ourselves of factoring. So just remember that we're going to factor, cancel, and if you need help with your factoring, please continue watching the video. All right, here we go. On the back, the top is GCF factoring. The bottom is trinomial factoring. So what 2 numbers multiply to give me negative 9, at the same time add to give me 8, and that would be positive 9 and negative 1. The r plus 9s are both binomials, so they cancel, leaving me with the final answer of 2 over r minus 1. Again, if you put that in parentheses, you can write them and it's correct, and if you don't write them, it's also correct, and there is no preference. Okay, this problem is very similar to what we've been doing, except we have the trinomial in the top, and we have GCF in the denominator. So in the numerator, we need to find 2 numbers that multiply to give me to negative 10, but that add to give me to 9. And that is going to be a positive 10 and a negative 1. The denominator has a GCF of 3. The y plus 10s cancel, leaving me with the final answer of y minus 1 over 3. Again, that doesn't have to be in parentheses, or you can write them. All right, 17. How are we getting a little bit more rigorous? Because we have trinomial factoring in both the numerator and the denominator. So in the numerator, we need to find 2 numbers that multiply to give me 6, but at the same time add to 5. And that's going to be 3 and 2. In the denominator, we need to find two numbers that multiply to give me 8 and that add to give me 6. So that's going to be 4 and 2. And so the x plus 2's cancel because they're both the same binomial, leaving me with a final answer of x plus 3 over x plus 4. Problem 18 is a very similar problem. We have trinomial factoring in both the numerator and the denominator. So what are two numbers that multiply to give me -4 and at the same time give me 3? That's going to be a 4 and a -1. Then I have two numbers in the denominator that multiply to give me a -8, but that add to give me 2. That's going to be, pardon me, I got the sign wrong. That's going to be a -2 and 4. The x plus 4's are the same binomial in the numerator and the denominator, and I get x minus 1 over x minus 2. Again, if you were feeling like you want to cancel out the x's, don't. Because if you replace it with your favorite x, they would not be equivalent. So again, if your favorite number was 17, 17 minus 1 over 17 minus 2 is equal to 16 over 15. If you cancel out the 17s, you get 1/2. They are not equivalent. So you cannot cancel an x that's in a binomial that way. All right, here we go. The numerator is still GCF factoring, but it is with a little bit of a twist. All of our GCF examples up to now just pulled out a number. But in this problem, not only can we pull out a 4, we can pull out an m as well. So I am left with 4n times m minus 5 on the top. Remember, you can distribute back to make sure you get what you started with. That is the beauty of factoring. The denominator, I have to find two numbers that multiply to -5 and at the same time add to -4. And that would be -5 and 1. We have the same binomial of m minus 5. So my final answer is 4m over m plus 1. Okay, number 20. Notice how neither of these are 3 terms. They're all 2 terms. But what is my first rule of factoring, friends? Our first rule of factoring is a GCF. This is a problem that is just GCF factoring in the numerator and the denominator, but I can pull out more than a number. In the numerator, I can pull out a 2x. And I am left with 3x squared minus 4. In the denominator, I can also pull out a 3x. And I am left with 3x squared minus 4. So see if you can follow along here. The 3x squareds minus 4 are the exact same binomial, so they can cancel. So I am left with 2x over 3x, but I'm not done because now you can treat this problem like we did problems 1 through 6. This is a monomial over a monomial. So I look at the number portions, 2/3. That doesn't reduce, but x over x can cancel. So 2/3 is my final answer. Number 21, the numerator and the denominator, again, are just GCF problems. In the numerator, I can pull out an 8x squared, and I am left with x plus 1. Because if I distribute 8x squared back to x, I get 8x to the third back. And if I distribute 8x squared times 1, I get 8x squared back. The denominator, I can pull out a 10x. And I'm also left with an x plus 1. So again, this is very similar to the last problem. I can cancel out the x plus 1's because they are the same binomial, which yields 8x squared over 10x. But now this is a problem like numbers 1 through 6. It's a monomial over a monomial. So now I look at the 8/10, and that reduces to 4 over 5. And if I have 2 x's on top and 1 x on bottom, I am left with an x on top. All right, friends, this is where this starts to get kind of ugly. Why? Because we have more intense factoring. Are you ready? On this problem, first step, both the numerator and the denominator, they both have a GCF. So I can take out a 5 in the numerator, and I'm left with y squared plus 2y minus 8. And in the denominator, I can pull out a 10, and I'm left with y squared minus 3y plus 2. Now, if I look on the interior, that has 3 terms. So I can factor that further by asking myself what two numbers multiply to give me a negative 8 and at the same time add to give me 2. And I believe we've already done a similar problem like this. I would have 4 and negative 2. So my numerator is this GCF of 5 times x plus 4 times x minus 2. My denominator is going to have two numbers that multiply to give me 2, but add to give me 3, negative 3. So that would be a negative 2 and a negative 1. So I'm going to recopy the 10, and I'll have x minus 2 times x minus 1. If you got this far, that was the hardest part of the problem, because the rest of this, the x minus 2's cancel, and so I am left with 5 times x plus 4 over 10 times x minus 1. But remember, I look to see if I can do any monomial reduction, and 5 over 10ths reduces, giving me a final answer of x plus 4 over 2 times x minus 1. Okay, here we go. 4x minus 20 over 3x squared minus 14x minus 5. The numerator is just GCF factoring. I can pull out a 4. All right, friends, here is the bottom. Here's what the issue is. When I look at the bottom, it's this. The leading coefficient is not 1, so we have to AC it. So that's what makes this problem a little bit longer. Is all of your homework the AC method? No. But let's review. All right, so how do we AC this? Let me pull up some extra paper. 3x squared minus 14x minus 5. Okay, to get the AC number, I have to take 3 times 5, which gives me negative 15. So I have to find two numbers that multiply to give me to negative 15, and at the same time add to give me a negative 14. So that's going to be a negative 15 and 1. So I am going to rewrite the 3x squared. I'm going to rewrite the negative 5, and I'm going to rewrite negative 14x as negative 15x plus 1x. And now I'm going to factor by grouping. I'm going to factor out a 3x to give me x minus 5. And I'm going to factor out a negative 1 to give me an x. Oh, a positive 1, sorry, to give me an x minus 5. So x minus 5 repeats, leaving me with a 3x plus 1. All right, now I am prepared to cancel. So the x minus 5's cancel, leaving me with a final answer of 4 over 3x plus 1. So really, this problem isn't hard. I would just say it's lengthy because you have to use the AC method. All right, 24. Let's put some skills together. All right, the numerator is in the same boat as the previous problem. In the previous problem, the leading coefficient is not 1, so we have to AC it. All right, so if I have, let's get some space here. All right, my AC number is going to be 6 times negative 4, which gives me negative 24. I have to find two numbers that multiply to negative 24 and at the same time add to give me 5. Those numbers are going to be 8 and 3, where the 3 is negative. So I'm going to rewrite the 6w squared and rewrite the minus 4, and then write this as a minus 3w plus 8w, and factor by grouping. So I can take out a 3w, which gives me a 2w minus 1, plus 4, and that gives me a 2w minus 1. So I end up with a 2w minus 1 times a 3w plus 4. All right, so that's the numerator. The denominator is a difference of two squares because it has two terms. So the square root of 4w squared is 2w. The square root of 1 is 1. 1's plus, 1's minus. So for my final answer, the 2w's minus 1's cancel, and I'm left with 3w plus 4 over 2w plus 1. And here we go for our last two problems. What's my first rule of factoring? A GCF. So I can pull a 2 out of the numerator, and I love this because I won't have to AC it. I have a b squared plus 6b plus 9. In the denominator, I can pull out a 3. So I'm left with the b squared minus b minus 12. So in the numerator, I need to find two numbers that multiply to give me a 9, but that add to give me a 6, and that's 3 and 3. Then in the denominator, I need to find two numbers that multiply to negative 12, but that add to a negative 1, and that's going to be negative 4 and 3. The b plus 3's, only one set cancels, only 1 for 1. So I can't cancel out both, just 1 for 1. The 2/3 doesn't reduce. Final answer, 2 over 3. And then I have a b plus 3 in the numerator and a b minus 4 in the denominator. All right, friends, thanks for hanging in there. Here's our last problem. And why is it a doozy? Because we have to AC twice. Is every problem in your homework like this? No, but here we go. All right, let me get some space. There's no GCFs. So in the numerator, 2 times 4 gives me 8. So I have to find two numbers that multiply to 8, but at the same time give me 9. That will be 8 and 1. So I'm going to keep the 2y squared the same, rewrite the last term of 4, and rewrite this as an 8y plus 1y. I can factor out a 2y, factor out a 1. The y plus 4's repeat, and I'm left with 2y plus 1. Now let's do the exact same thing in the denominator. So in the denominator, I have 4 times negative 3, which gives me a negative 12. I have to find two numbers that multiply to negative 12, but at the same time add to give me a negative 4. And that's going to be a negative 6 and 2. So I'm going to rewrite the first term of 4y squared, and the last term of negative 3 is the same. And then I'll rewrite it here as 2y minus 6y. I think that's how a lot of you would probably group it. So I can pull a 2y out. I can pull out a negative 3. And I'm left with 2y minus 3 times 2y plus 1. All right, so to finish, we can cancel out the common binomial factor of 2y plus 1, leaving me with a final answer of y plus 4 over 2y minus 3. I hope you found this informative and you are ready to do numbers 4 through 15 of your turn-in assignments. If you have any questions, I'll see you in office hours on Tuesday and Thursday.